Cool. Awesome. Howdy. Oh. Hello, Ember NYC.
Hello.
Here. Hello. Help. Should I do anything with this?
Maybe the volume knob on the wall behind you.
Oh. Ooh, nice. Excellent. Okay, is that okay? Can everyone hear that all right? Yeah. Over the sound of the air conditioning on this delightful New York day.
Whoa, like a 4-second echo.
What's up with that? I don't know.
It matches with the videos.
Yeah. Well, if everyone in the room can hear me okay, then I won't use it. If I can speak up, Luke, is that going to work for you?
Well, I'm just worried about this.
Yeah. Can you guys hear everything okay? Yeah?
Because that's from the other mics.
Yeah? Okay. Okay. Sounds great. Okay, well, welcome to Ember NYC attendees here in New York and attendees on the internet. It is nice to see all of you again. We have an agenda for today which has 2 talks on it, which I didn't add to the slide. I guess I should add them to the slide. But just to start off, announcements, if anyone has anything that they'd like to share with the group before we start off here. We don't have a microphone, I'm sorry.
That's okay. Hey, I'm Gaurav. I'm still available looking for work. If anyone's interested, let me know.
Anyone else? Okay. Awesome. This is maybe Luke's final meetup. So thanks for joining us today. I pulled some quickie stats from the Meetup database, as it were, and Luke has run probably like 130 Ember meetups. Yeah, I mean, Arity, like, maybe 10. About 2,000 members in the group, over 2,000 members in the group. The highest attendee count for any Ember NYC was 245, according to Meetup. The lowest was 8. That was like the 4th Meetup. So, yeah. So pretty cool. I would like to at least have everyone here just give Luke like a round of applause and just thanks for, I think, playing, for a lot of us here, playing a very important role in our careers and our professional lives and being like a friend and a mentor to us in a lot of different ways. So thank you, Luke. You can come back anytime if you have a talk. And then I wanted to just quick brainstorm if anyone in this room has ideas for people who they'd like to hear from. There are a couple other Ember core team members here in New York. And there are also like different people in the Ember community out there who are doing interesting things. And I was curious if anyone had names that of people who they'd like to hear from that we can try and recruit for this this summer and into the fall. Any ideas off the top of anyone's head? Okay, once you think about it, maybe we'll come back around to it, or you can always we can always talk about it at the bar later on. But
It would be nice if we want to get Jen Weber down.
Jen Weber down? Mm-hmm. Would be great. See, I'm like literally taking notes here, so this is your chance. Actually, I'm not literally taking notes because this doesn't work. Yeah. Okay, great. Yeah, so please do think about that because I think that's a good way for us to get people from out of town to come in is if we tell them, hey, people want to hear from you. And then we're going to do 2 talks tonight. I'm going to give us a lightning talk on some data loading hacks, like examples of 2 specific hacks, and then just some other like sketches of ideas of things that you can do when you're trying to make an app work a little bit quicker, a little faster with Ember data or anything else. And Luke is going to talk about Orbit, which I'm definitely looking forward to since we have some data layer issues where I work as well. So to talk about some data layer hacks. I'm going to try not to sit on this microphone. Oh, there we go. OK, that seems great. So yeah, we have a couple of challenges when we're doing data loading in the browser. that make it hard to make things just fast out of the box. And often, like, we have pretty naive setups when we just start by calling $.ajax or something a bunch of times. One challenge is that everything is single-threaded. Like when we control work in JavaScript, we're doing everything in one thread, and it's blocking, so we can't have multiple things happening at the same time. There's a problem of what's in the queue. It's a little bit hard for us to know for sure what other work has been scheduled into the future. Like, we can do the bookkeeping ourselves, but we can't know if the user has clicked a bunch of stuff and it's added a bunch of tasks into the macro queue. Like, there's no way for us to detect that and know if there's something there, so we should cancel our work or something else. And I think a normal problem, a pretty classic problem, is that we have a little bit of trouble understanding what's actually causing the work. There's a little bit of DevTools knowledge can help you on this stuff, but it's still just confusing to understand. Am I having problems because of how work is scheduled, or am I having problems because of the actual work that has to be done, the amount of work that has to be done? Is my problem in like the rendering layer, and I'm looking through this confusing stack trace because it's a VM running inside of a VM, or is it something else that's not related to rendering, but it just looks like it's interleaved? So I think there are some opportunities. One is that I/O can actually be parallel. So anything that we can do where we can say, I'm going to be doing some JavaScript work right now, let me get the I/O going, because that can actually be in parallel, is going to be really helpful to us. There's some neat tools like request.callback that in of themselves don't necessarily like solve a problem entirely, but they provide really easy ways for us to say when the world has calmed down. Often there's a problem, especially in Ember apps, with like a lot of Ajax requests that go off where they're all coming back, and they might be coming back on top of each other. And so you might have like one response that causes a render and another one, and then the user did an action and it's rendering, and you have no way to like know when is the system cool so that I can decide that I want to do some work. And request.callback is going to help us with that. And then of course we can talk about the implementation of these things, and we can actually make some better decisions. So the first one I'm going to do is take a look at preloading. We're going to start fetching data before the JavaScript of the app even kicks off. We're going to look at how we can make that kind of seamless. And then we're also going to look at batching, how we can avoid causing every single XHR that we make. How normally an XHR comes back, your promise resolves, you change something, you cause a render. Well, if you have a lot of those coming back at once, how can you batch them so that you get one run loop in one render pass instead of getting multiple render passes? So let us take a look. "2019, year of Linux on the desktop." Fantastic. OK, so I have an app here, and I think I can just actually load it right up in the browser here. Yeah. Let's take a look at using this window. Looks good. So I've got this running at localhost 4200. So this is a simple application. Let's maybe blow it up a little bit. OK, so what this app is going to do is I visit index here, and I have a click to visit dashboard. I click visit dashboard, and it's going to do some loading of items. If I pop over to our network tab here, we can see that items is this XHR at the bottom, and it's pretty big. It's coming back. It's like 21 megabytes, so there's just a lot of data in there. We can see that there's another request here of authenticate. Well, let me maybe clear and reload. I'm just going to cut this off before items finishes, and you can see in our waterfall over here on the side, we load all of our JavaScript for the website, and then we kick off this request for authenticate. We find out, is this user authenticated or not? And then we actually go and fetch the items. Then our items populate on the screen here. Each thing seems to have a title and a date that goes with it. How are we actually putting this together? How many of you have used HTTP mock in Ember CLI? This is a pretty fantastic tool to use for prototyping when you want to basically start designing an API without having to build any of the backend. And it makes actually a great tool for you to work with someone who works on the backend, and you have like a common spot where you can discuss exactly what an API should look like, what it should expect, and what it should come back with. So in this case, I am using HTTP mock. So I have two mocks that I've created. One mock is authenticate, and we can see what it does here. It handles this URL here, API/authenticate, and it's going to time out after 300 milliseconds, and it's just going to send back this current user. And I have another mock for items. And items does something a little bit more annoying because we just want to make a big old data payload. So it returns actually 1,000 of these items, and then it also fills up extra noise to make a super long string. And this comes back after 450 milliseconds. So I think these are like semi-realistic API times for like a not super well-tuned application. Probably not uncommon for a lot of developers' experiences. The way that these things are actually being loaded up, if we want to find out how data is being loaded in our app in Ember, we should probably start at our application route. So that's where we can start here. So this is our application route, and we have a session we call session authenticate. If we go ahead and pop open session, we can see this authenticate thing just calls this.ajax. That's the Ajax service that comes with Ember Ajax that's installed by default in Ember CLI, so there's nothing too fancy going on there. We call that API authenticate, and then when we get the response back, we're pushing it into the store. So Ember data is not being used to create this request, but we are then pushing the stuff into Ember data so that we have access to it and returning that record so that we could render it or something like that. The route that we were on was the dashboard. So here's the dashboard route, and we can see that calls store find all item, and that's how we fetch our big old list of items. So this looks like it's not so bad, right? Items is super slow, but if we, like our authenticate is not so bad. It's 300 milliseconds here, and that's like kind of okay. Let's see what it would look like for someone who was not working on localhost, and try it again and disable our cache as well. Let me just reload it. Oh God. Oh no. Wait. And then Vendor.js will finish soon. Soon. Oh, it finished. Now we're authenticating. Okay, and now we're working on items. Okay, and we know that items is going to be pretty slow. Okay, so a thing that we already know that was kind of silly here is as we're doing this, we have the opportunity here to parallelize some of our I/O. We're doing a thing where we are waiting for the vendor JavaScript to load before we do something that we know is always going to happen in our app. Nobody's going to show up at our app, and we don't need to authenticate them, right? We always need to know this information. So let's see if we can move it around and call a little bit earlier. Luckily for us, the author of this application has a helpful branch called done that has a couple commits on it that will be useful for us to look at. So let's maybe just take this SHA here. Yeah, I think is actually the only thing I need to do. And let's just take a look at it first. So this is a diff, and I'll actually, I'll patch this onto my code here, and we can take a look at what it's doing. But we can see it's going to do really only two things. The first thing we're going to do is if we want to reload something, if we want to do some I/O before Vendor.js ever loads, we need to actually put something in the HTML, right? We can't we could put it maybe at the beginning of Vendor.js, which would be like another approach that we could try and take. But the simplest thing would just be to put a script tag in the document and put it in here. We also need to change these script tags to defer. If we don't change them to defer, then Chrome is actually going to try and fetch them because they have a URL first. And we actually don't want that. We want them to run later, and we want this to kick off for sure first. And then the other thing we're doing here is we have a little dance going on up here. So we're setting up this callback that just stores our data on a property called authenticate response to the window, and then we're also setting that up on a hook. And then we call this XHR, and then we call the response.json. If you've used window fetch before, you have to tell it to read the body of the response. And then we actually call the window on authenticate response with the value that we got back from the JSON. All we're going to do is in our authenticate hook, instead of making the AJAX request ourselves, we just look to see if the response is already there. So basically, did the request already happen in return and this callback was called, and now it's just stored on window? If it's there, then super. We can just call promise resolve and we're done. We actually don't need to do any fetch at all. We don't need to wait for anything. But it might not always be there, and if it's not there, then we just return a new promise, and we just look for, we basically add ourselves to that hook. So we stomp the hook for on authenticate response, we set it to be the resolve of our own promise, and now when this finishes and it calls this, it's going to call our version of the hook. So basically we had one implementation that if it resolves before Ember ever boots, it will just store the value somewhere convenient for us. But if Ember wins and boots up before the response comes back, then we still want to be able to attach to that pending request that's currently out there in the wild. So let's go ahead and apply this patch and take a look at it. Actually, I should probably just do this. OK, so this was our previous timeline. Let's go ahead and do a new one here. So you can see our authenticate already kicked off and completed, even though vendor is still coming down. Guess I should do fast 3G instead of slow 3G, huh? Yeah, and then once our vendor finishes, our JavaScript runs, and we immediately kick off our request for items. So now that authentication, that work that we always know has to happen, we're doing in parallel to actually fetching the running application itself. So this is a prefetch pattern. I'm not sure if there's an add-on that does this. Obviously, we haven't covered all the edge cases, but like as an idea for you to explore, the nice thing that I really, really like about this approach is you don't actually have to change any of the code in the application besides hooking up to the pending thing. There's like no logic changes that you make to any of the code in the app. So this is an easy optimization that you can make without needing to mess with running stuff. Shoot.
What if the person inspired is between the time when the authentication prefetch finishes and JavaScript loads, and their authentication status will change?
I thought you meant fired as in like they lose their job.
No, that's it.
What if you need to maintain this code and the author is fired? No, sorry. What happens if the
I was joking. It's based, I was saying if they were fired in between.
Yeah.
Because you run it ahead of time. Well, it's more of a question of like you're basically caching authentication response. In this case, obviously it's okay. It's within the loading state.
Right. It's in the download time of vendor.js, which
Exactly. It made me think of like, when you do this kind of thing in fast food, the fast food could serve up a page that has authentication data in the shoebox.
Right.
So that you don't ever wait on that. When you first load the page, if you have data that's not stale and cached in Ember data, then your data loading logic can say, yeah, return exception ID current. And if we have it, we know we don't have to wait. We don't have to block it.
Yeah. Sam is suggesting that if you are using, for anyone who can't hear, that if you're using if you were using Ember Fastboot, for example, you could authenticate that user dynamically, and then you could embed all that information inside of Shoebox or just somehow into the page as a data payload that's then loaded up by the running application. Definitely true. The reason I think that this is an interesting approach to talk about is mostly that you don't need to adopt Fastboot in order to use it, which, yeah. It is definitely in the category of hack. So in the spirit of, yeah. So any other questions before I take a look at another thing?
Is there any reason not to make defer part of the standard blueprint site?
I don't think so. I'm pretty sure it should always be deferred. Yeah, well, Luke was asking if there's any reason why defer is not part of the standard blueprint, the standard HTML file. And I have wondered the same for a while. I don't think there is. I think there's probably just like FUD. I think people are like, what happens if I do defer? Am I breaking some edge case? But there's no circumstance in which Ember's vendor.js or Ember itself should be calling document write or anything that would break when you use defer. So I think we should be able to make it part of the default blueprint.
Well, I like this. When would you, like, when do you know to lift this data loading out of your router before the Ember application loads? Like, would you always do this?
So I think, yeah, the question is when do you know to pull data out of your routing layer and into a solution like this? I think that it makes a great sense for stuff like authentication that's universal. For anything that's not universal, it quickly, I've also used it in those cases, but it quickly becomes much more complicated because suddenly you have to basically have a little routing engine that sits in your script tag there. And the initial payload going to the browser is actually pretty forgiving, so you could throw a lot of content into that script tag and have a whole thing of like, check window location. If it's this, then kick this. If it's this, then kick off this request. But that obviously, I think the problem there is it becomes harder to maintain. In a full implementation of this, you probably don't, the implementation that I do in JavaScript here doesn't handle the case when for whatever reason, the script tag itself wasn't present. Presumes that the script tag is always there and executed. And I think usually I write it in production in a way that is safe for if someone deleted that code for whatever reason, it would still make a request on its own. And that way it's just like safe in all circumstances. You don't need to worry about it. OK, cool. Let's look at another little thing here. OK, let's see. OK, so in this case, there are a few changes that have happened. I think I can speed up our world here a bit. Actually, let me just speed up all the way at the beginning so I can see what we have going on here. Sorry. Yes, let's take a look at this. So I'm going to disable a thing and then show it to you because I don't want to spend all of our time looking at this. So let me just get rid of this and this. And I think of this. I wrote this in a clever way. That means that I think it should be pretty straight ahead for me to just undo. Great, it worked. OK, so in this case, we've got something only slightly different going on. The page this time is loading up first. We fetch vendor.js and all this stuff. We still call authenticate, and that seems great. We call items. And then at the end of items, when items finishes, you see we have this waterfall of requests that happens. And each of those requests is for like 0 through 9. Basically, for each one of the things that is being rendered, we're fetching some additional data. And I think this is also not necessarily an uncommon thing that you run into. This is implemented inside of this detail component. So basically sorry, I should look at the template first here, which would be in our dashboard. So here's our dashboard. And in the dashboard, I'm iterating through filtered items, which is just the thing. We had, I think, 1,000 items that we returned in the API response, but we're only showing 10 when we look at the screen, which is another classic foible, of course. But when we actually render them, as we render them, we then call this detail component, and we happen to pass it the ID, and then it is causing additional work to be done. It's causing this AJAX request to be kicked off, where it's going to call it API detail for whatever reason, and then it's going to set detail, and then in its own template, it just renders the note. So the note value here is this wow item ID, no way. That's coming back for each of these individual things. So this seems kind of neat. In this case, we ran it, we're running this without throttling, and we can still see that there's like a big waterfall here. Why aren't these things closer together? Why might not they be like right on top of each other? Like, shouldn't they be basically like so fast that there's no time in between any of these responses showing up here?
Is the browser limiting the number of requests?
It's true. The browser could limit the number of requests, and especially older browsers did do a lot of throttling of stuff. I think this did not work. I need to manage the recording myself here. Let's take a look at what the performance profile looks like here. So if we look at this performance tab, we've got like a lot of information in the performance tab here, and we can see the items, and you can see here each of those requests being kicked off. And if we look right here at the beginning, we can see that we have a task, which is running when items has come back. And then here's our load of items. So here's our XHR from items has come back, and now we're going to do some JavaScript. So we run some JavaScript, and as we're rendering, we're kicking off each of these things. So because you might have noticed in the template, I had a thing called like expensive component there, which just is artificially generating some higher latency for us, like you might see in a real app. And so in between here, we have like almost 400 milliseconds in between each of these actually kicking off their XHR requests. Let's look at what the end of the work looks like. So we can see at the end of the work here, as each one of these things come back, we have to kick off an XHR to actually, we have to kick off a call stack. We have to kick off like a callback to actually do the work after our XHR is completed and set that detail property and then have it show up on the UI. I think we could even make this more accentuated. So this .detail is the thing that's actually being set. So I think this might be a better example here. If we say, if we have detail, then render these expensive components. And now our callback should be the thing which is slow instead of the initial thing where we're sending off the request. So let's clear this and reload it and give it a look. Yeah, so this looks maybe like what I think is more of a real world example here. Each one of these network requests, you can see they all kick off very, very quickly during their initial render. But now, because we have wrapped in that if statement, we wrap the expensive things in the if statement, we can see as each one of them comes back, we have to do a rendering pass. And the rendering pass has 2 of those expensive components, so it's actually really slow. So we end up having this waterfall effect. What's weird about this is that the way that the network tab is, the way that the performance tab is showing us this is showing us like a big problem here. The Linux on the desktop is not perfect, I will say. So you can actually see the requests themselves. That's the request. Like, it's done, right? The request was fired off and it finished. It actually finished before we even finished doing the initial rendering. But then we proceeded to need to process each one of those things that responded one at a time. And each one of them took a JavaScript stack as well. And each one of these stacks was another 400 milliseconds. So we took a bunch of API calls that were like 20 milliseconds or something like that, and we stretched them out to each be 400 milliseconds of rendering on the client side. So this is no good. This is not very fun. What are some, does anyone have an idea for what we could do to address this?
Try to wait until you get all the responses back.
Yeah, we can try and batch the responses. So let's take a look at that. I think there are some other approaches. You could try and batch the request. You could be like, just batch up all the IDs that you need and like send them to an API that gives you back all the stuff all at once, and then you have one frame where you render it. Might be another approach. But I think in the idea here is to do hacks that just let us solve the problem. So let's take a look at a hack that lets us solve the problem without needing to change a lot of our code. What I've written here is a batch service, and it's going to do a little dance for us. So it's importing RSVP using RSVP promises. The API is such that we have really just 3 things here. We have add, and what add is going to do is say, give me a promise, and I will let that promise run. So I'm going to just like, I'm going to do my own promise here, but I'm going to call promise.then. So whatever promise you pass to me, I'm just going to handle the callback for it. And I'm going to return you a promise. So basically, I've wrapped the promise that you passed me in another promise, and that allows our logic here to control when you get a response from the thing. So instead of at promise then, like we don't just immediately call resolve in here. Instead, when it resolves, we push it onto a list of queued responses, and then we call schedule flush. Schedule flush the first time that it's called, and only the first time that's called, will schedule a request that I'll call back that actually has our real flush method, so that if you have multiple things being pushed into the queued responses, then they'll just get added up, and eventually when you get your flush, you'll iterate through all those things. Our flush wraps everything in a single run loop. So we have run, and then inside of it, we're going to walk through and resolve all the promises. Remember, this resolve, which we're reading off of the array here, this resolve method is the resolve that we have from this promise up here. So now we're controlling in one run loop. I want to resolve all of these things at once, which should mean that they get one rendering pass instead of a bunch of rendering passes. This is not like totally transparent, because I now need to add it to all the promises where we want this batching behavior. I think that this API is kind of cool. But when I've actually done this in the past, usually in most apps, there's like a central AJAX thing that even Ember data is passing through, and you kind of just like add it at that point, and then you don't need to worry about it for the rest of the system. But this is kind of neat in that it allows you to arbitrarily do any like promise, even if that promise wasn't in XHR, which is kind of fun. So let's take a look at doing that. So the thing which is actually making the request is in detail component here. So we could actually add it in the like right here in this AJAX request, but because we're using the AJAX service, We can also just go ahead and add it to anything that happens to call the AJAX service, which makes it a little bit more universal. So in here, we already have the batch service installed. So let's say batch.add and wrap this thing. And now let's take a look at what our timeline will look like. OK, so now we have items here, which is waiting a whole bunch of time. And now look at our request response list. It's like much, much shorter, right? We don't have that big stack of things. In this case, because I'm like creating an artificially large amount of work in each of those promises, I'm not sure that we've saved a lot of absolute time. But I think in a real application where each of those responses is actually going to trigger a whole cascade of other logic in the system, you actually do consolidate like a lot of work. And I usually see pretty great benefits from adopting this.
So expensive component is expensive in terms of the main thread.
Expensive component, basically just a while loop that locks the main thread for 240 milliseconds here. Yeah. Yeah, it's deterministically annoying.
But it's not like expensive in the sense that it's taking a long time asynchronously to respond. It's literally blocking the main thread. So it's causing a problem. Whereas like another category of problem is like if you have an n+1 problem, it's the network process, but your UI is not blocked. But here the UI is blocked.
Right. Yeah. Here, like in the like really what we're doing by batching the responses here is we're enabling ourselves to do one rendering pass instead of multiple rendering passes. And I mean, it is pretty easy to presume that if you had a choice in between calling render 10 times and calling render once, you would prefer to call it once. You will get a better result out of this.
Batch uses request idle callback.
Yeah.
Is request idle callback not fire when IO is occurring?
What request idle callback is essentially doing is waiting for the system to be idle as defined by the spec. I'm actually not exactly clear what that is, but basically there's nothing in the macro task queue that's immediately looming. So for example, if I click the page 50 times, request idle callback will not land in the middle of those 20 clicks or whatever. It will wait till all of them are done and their processing is done, and then it will let the idle callback happen. There is I think there's even a warning in the browser, is a strongly suggested second argument to request idle callback, which is a timeout. Because there is no, if you do not provide a timeout, there is zero guarantee your thing would ever call. And if you imagine a more CPU constrained device, like it would just, it's possible that the user is clicking and doing stuff and like your system is churning all the time.
This makes sense to me because it's so tightly tied to a server request. But it seems like you could get yourself into a case where it's kind of brittle because it's not actually updating when you want it to. Because, you know, if you batch it incorrectly or...
So you do, yeah, the comment is like it's maybe a little bit more brittle, or it certainly causes a behavior change. You're not processing the API response right away. I think my pushback would be that your code should not be presuming that it doesn't share a run loop with something else. And it probably does not unless you're working very hard to make it work that way. So that should be safe to like put all these AJAX responses into one thing. That shouldn't be a problem. And the second thing is that basically the order that they're going to fire in the timing was never guaranteed anyway. You never knew when the API was going to come back anyway. So if you're going to use request idle callback, if it shifts the earliest response by like 20 or 30 milliseconds later, and again, you can control it with the timeout, but if it like shifts it by 20 or 30 milliseconds later because it waits for other things to come in and then does its processing all at once, you've actually you may save yourself more than 20 milliseconds of rendering time and thus easily recoup the loss of using like the deferred thing. Another thing that I've done in production versions of this is when you're processing the responses, when that flush command happens, when the schedule, there's a point at which you can identify that you only have one thing in flight, and you can say like, I don't need to wait because there's nothing else in flight, just flush right away. Yeah, it's in schedule flush. Yeah, when you call schedule flush in here, you could also say like, if I actually only have one thing in here, like I don't actually need to wait, just like if I know that there's nothing, you can't do it with this, I'm sorry. There's a different way where, because this is just tacking onto a promise, there's no way for us to know when the asynchronicity started. But if you wrote your own version of this inside of XHR, you can know when you start a request. So thus, when you go to schedule a flush, you can say, if I've only started one request, there's no need to wait. This is it. So just go ahead and flush. So that means that in cases where you only have one XHR, this is free. You have 0 loss of time, which is pretty nice. Any other questions about this particular hack? Fun stuff. Cool. Yeah, so those are my 2 put together things, and I'll push that repo up somewhere if people want to look at the implementations of them and poke at them and maybe mature them into something more production ready for your own uses. Some other hotspots and ideas. Ember data transforms are eager, which is a common trap that I feel like people fall into. Like they'll say, I will make a bespoke date type. And for all my date types, I will just moment parse the string that comes back from the server. Moment parse is like abysmally slow. It's basically a long list of like regexes and then like a try catch around each one to see when they fail. It's very, very slow. If you move that stuff into helpers or computed properties, then you'll end up using it less. So for example, we fetched 1,000 items in our AJAX request, but we only showed 10. It's going to be a lot faster for us to use a helper to format our dates than it would be for us to parse 1,000 dates for no good reason. Especially if you have stuff like created at and updated at and you're just blindly shipping it to the client, you could really be trolling end users by using transforms. Why do we need to create Ember data records for the whole payload? I'm not quite sure if we always need to. I don't know exactly how to balance that, but it seems like a thing that we should be able to be a little bit more lazy about. Like we maybe don't need all the data right away. I guess maybe the craftiest hack version that I can think of is like, if your API doesn't support pagination, then write a service worker that adds pagination so that the in-browser thread only ever has to deal with the subset of data, and then the service worker can keep the huge long list. Seems like it would be fun, and again, would like not mean you wouldn't have to mess with the server and you wouldn't have to mess with your app code that much. Ember M3 is a schemaless model definition that LinkedIn uses. So instead of defining a schema for all their data types where you have like title and or title and name and things like that, it just, whatever the server sends back, it calls the schema. And they can save a lot of memory by doing that. So this is an interesting project to look at. If you have tons and tons of models and different schemas, it might be able to save you a lot of time. And then can you maybe batch operations? So a good example is in this, we said that we can maybe batch the request instead. So instead of requesting from details 10 things, why couldn't we have put it in one request that said, give me like, 1, 2, 3, 4, 5, and 17, and just give them all one response. So that would be pretty nice. And I think that's it. Any other questions or anything? No? Yeah, that repo. Yeah, I'll push up to GitHub this evening. Yeah. Cool. Luke?
We've always wondered and never really looked into it, but Ember data transforms like the standard ones, like string or number, whatever. Do we actually have performance gains by leaving those out also?
No, if you leave it out, it's string. So I don't know. I think the only
Number in JSON?
What's that?
Even if it's a number in the JSON?
Yeah, I'm pretty positive it's a string always.
I don't think so.
You don't think so? You think it's dynamic?
It's untransformed.
Yeah.
Because I've used nothing.
But you don't get like an
little
object.
JSON blocks.
You don't get objects back though, right?
If you
Yeah, if you leave it blank?
Yeah.
Okay.
So it makes me wonder, like, if you have strings, if you're saying like add or string for all these things, if it's doing something like 2 strings.
Yeah, maybe it would be cheaper just to leave them out. Yeah. Yeah. Okay, cool. Thank you very much. If everyone wants to take like 5 minutes, and then we'll come back and Luke will talk about Orbit. Thank you. What do you need for cables in the ilk? You don't have a headphone port. You have a headphone port?
Yeah.
It's like the last one with the headphone port, huh?
Is yours? Oh, yours.
No, mine
I
has
don't know. Did they get rid of it on the latest?
On the new ones? I guess you're right. No, they didn't. No, I think my 15-inch doesn't have it. I'm pretty sure my 15-inch doesn't. I just turn this on.
Oh, yeah.
And just now it's blinking green.
Turn it off. Just hold it down until it turns off. That's fine. We'll just see how long it lasts.
Okay, so I'd like to welcome,
You're not talking.
with the microphone, I would like to welcome. All right, I'd like to welcome first-time Meetup speaker, or so if you hosted, what did I say?
130?
130, so then you've probably spoken at 40.
Yeah, I don't know about that many, but
Yeah,
a lot.
Let's say for his 41st Meetup talk here at Ember NYC, Luke Melia.
All right. Oops, didn't want to print it. So we're going to talk about Orbit.js, and yeah, get into it. This is me. Real rock climbers use their bicycle helmets when they're rock climbing. Not really. What to say about this? Yeah. Oh, I'm moving. As Matt mentioned earlier, I'm moving to Southeast Asia, eventually Singapore. We're going to take a few stops along the way, leaving in August. So today, what I want to cover is a little bit of background on Orbit.js. Basically, what is it as a background, and also how does it differ from Ember data, since we already kind of have a standard data layer for Ember. Tell you a little bit about my use case, why I picked up picked up Orbit a few months ago to do a spike and ended up really falling for it. Basic modeling with Orbit, so understanding some of the Orbit primitives and how to use them. Ember Orbit, where that fits in and what it gives you on top of Orbit.js. And then extensibility. And in that section, we're basically just going to look at some real-world code. And we can kind of go as deep or as shallow as interest and time allows. So let's get started with the background. So first, I'll introduce you to Dan Gebhardt. Dan is the original author of Orbit and the primary maintainer currently. He's also a member of the Ember core team, the Ember data core team. He's an editor on the JSON API spec. He consults under Cerebrus, and you can follow him on Twitter, recommended at dgeb. Dan was an early contributor to Ember data, and it was partially as a result of that work that he decided to start work on Orbit.js way back in June 2013. So to me, Orbit feels really new, and it's actually kind of amazing. It feels like a very fresh project. It's in a monorepo. It uses TypeScript. The documentation's pretty good. It's like super clean, but it's been around 6 years, and so that's a testament to Dan's persistence and professionalism, I think. So in January of 2014, Dan first presented Orbit to the world at Boston Ember. And these were some of the challenges that Dan described that he was hoping Orbit was going to be able to help people solve. Asynchronous UI. So this one we sort of take for granted, but like the option of when you take an action, kind of waiting for the server to respond before you show the update, or immediately giving the user positive feedback. I think we sometimes call it optimistic UI. Offline support. This was the one that drew me in. We'll talk about that a little bit later. Undo, redo. I'm not going to talk about that today, but I will hopefully touch on kind of the fundamentals that make that possible in Orbit. Data synchronization we'll talk about. And editing contexts. This you may be familiar with as a concept of store forking, but this solves the basic problem of I'm about to edit a record. When I have the form open, I don't necessarily want the rest of my app responding to me, having a data-bound first name that I'm changing, or worse, some like security. I can set it on the set it on here if you want.
Yeah, I have no idea why.
And try to keep an eye on it. Cool. So for the folks we lost at home, it's like the slide says, what's the relationship between Ember Data and Orbit? And we're going to look at Dan's, a clip from Dan's talk in last year's EmberConf about that.
So how do I see Orbit fitting in with Ember Data? Well, as we've already seen with Ember Data's incremental scale, there's a big question mark, a lot of question marks at that upper end. You know, where does it go? What's next? I see actually a lot of issues opened in the Ember Data RFCs and the repo about, you know, pushing advanced capabilities. And I'm hopeful that those advanced capabilities that we all need as a community line up with a lot of what Orbit provides. So I think
We just hear
We got the crux of it.
Oh, sorry.
It's okay. The other thing that he said that Dan described in his analogy is that similar to the way that the community and the core team kind of massage some of the rough edges of of Glimmer and the Glimmer components to bring them into Ember, we could potentially do the same, something similar with Orbit. And that Orbit could function potentially as an experimental experimental area for bringing ideas into Ember Data. So what we just heard from Dan, this is a vision. This is his take. This is aspirational. The reality for an app developer today is that Orbit and Ember Data really are alternatives. They do the same thing. More or less. I think you can make a pretty strong case that Orbit is capable of doing more than Ember Data can. And I think that that's largely because of architecture and not because of like amount of code or something. And I think you could probably make a case that Ember Data is a little bit easier to learn than Orbit as well. However, it is possible to have these things coexist if you're in a situation where, like we are, where we already have an app that's using Ember Data, but we're really eager to get some of these capabilities that Orbit can bring to the table. So let's talk a little bit about the use case that led me to this. Why did I care about this? Should you care about it? Quick primer on Yap. Yap lets customers create mobile applications mostly for events, and common features in these mobile apps are things like schedules, speaker lists, shared photo galleries, and more. So for the last many years of Yap, we've had two types of app content. What I've sort of thought of as static and dynamic. I also sometimes describe it as like published or editorial and social. So on the static side, stuff is published from time to time by app admins using our editor. And on the dynamic side, it's social content that's updated frequently by end users. On the static side, what we do is we take this kind of published JSON blob, we cache it on our device offline, so that for offline access, so that when you open a Yap, if there's not been an update, you're using it's opening quickly and you're seeing all the content that's from the last publish that's been cached. On the social side, we want that to be live. And so we're going to fetch that from the server. We're going to cache. What we do is previously with Ember.data is we sort of cache the most recent response. And we do this through some adapter hackery so that we can at least show you something. And it's similar to the way Instagram works. If you are an Instagram user and you've accessed it offline, is like there's a few images there, so it kind of looks like it works. But if you try to do anything or you scroll down, like there's really nothing else there offline. So that's the approach that we took. The left side only changes on publish. The right side changes all the time, frequently. More users, more frequently it changes. So in listening to our customers, which I highly recommend for startups, people were asking us, hey, can users add themselves to the attendees page? Can users upload a photo of themselves? So I've listed the attendees, but I don't have pictures. Can people upload their own photo? And we heard this over and over and over again. And so we decided we should do something about it. And so we designed a feature where people would be able to add themselves and edit their profile, claim an existing record so that they could enrich what the app creator had put into the app. And we set out to model how are these new features going to work. So our existing models, and I'm describing sort of back end and front end indiscriminately. This is our kind of conceptual models. We have pages, we have persons or people, and then we have a join table that associates people to those pages. And that's all part of our published data, the left side that I was kind of talking about. That's all we had going into designing this feature. So then we said, okay, well, we could also have profiles, which are something a user can create, and page profiles, a join to a page, so that profiles would be able to show up on the page. And then lastly, we also would want to have a person claim record, where it's a relationship between a profile and a person. And so as we started to think about this, the idea with the person claim is that when we're rendering a list of people, we would, and some of that was coming from the editorial side, we would say, hey, have any of these people that we're about to render been claimed? So do they have an associated profile by way of a person claim? And if so, show that instead, right? We want to show the richer data instead. And as we started to think about this, we realized we really have a new type of app content, something in between static and dynamic, something like maybe we describe it as persistent. And it can be updated at any time. Anytime we're hitting the server for new info, we may have new profiles, new person claims. But really it should be, if the user's seen it once, they should see it all the time. Because it would be a really weird experience to go and see this rich data about people, and then you come in and you're offline, and all of a sudden everybody's photos are gone, and it's just their first and last name, and all their social links are gone and stuff like that. So this was the driver that led us to say, okay, we've been wanting to be able to have a good solution, an elegant solution to this offline problem for a while. This feature really, really needs it. Let's look at some technology. Let's do a spike. So that brings us to basic modeling with Orbit. And what I'm going to do is I'm going to kind of talk about the Orbit primitives. And I'm going to show you, in the context of the problem I just described, how we apply them. So the power of good primitives. It's pretty awesome. So this now gets into the part where I talked about, we have these words, this language that some of it might make sense, some of it may be a little abstract. And I think in my experience, there's definitely a learning curve around this part. Is what does Orbit mean by a source? What is a query exactly? What's a transform? How do these things relate to each other? Now, I found personally that in about 1 day of playing with Orbit, 1 day of working with it, I started to have a really good sense of this stuff. But it did take that long. It wasn't something where I could just read the docs in a half an hour and be like, okay, I get it. So let's start with models, records, and schema. So I skipped this slide. Nope, still skipped it. Sorry, animations got out of hand. Okay, so Orbit needs a schema definition that it can provide to its sources so that its sources know how to deal with the different types of data that you're going to be handing to them and how to update, et cetera, that data. So a schema consists of basically a set of models, and models are defined using this simple definition. And so you can see this is probably pretty familiar to anybody that's done Ember data work or JSON API work, attributes, relationships. One thing very clear working with Orbit is you can tell that the creator is an editor of the JSON API spec. The internal format that records are stored in to be passed around between sources and manipulated is JSON API, essentially. So schema definition. A record is conceptually is an instance of a model, but practically is just a POJO in Orbit. And it's specifically a POJO that has a type and an ID property. And that's how, when used in context, Orbit knows what to do with it. We'll see later, Ember Orbit kind of adds its own layer on top of this. But for now, I'm describing just what Orbit provides. So sources provide access to data. And Orbit has these first-party sources. And at first I wrote Orbit includes these sources or ships with these sources. But as I mentioned before, Orbit's a monorepo where they publish several packages. And you don't need to, or wouldn't, in fact, would not typically include all of the packages that are published out of this monorepo. So specifically, JSON API, you're almost always going to use the memory source. And this is what we think of in Ember data as a store. It's the in-memory thing that is an identity map where you can query against it, et cetera. But these others, you may or may not use depending on what your app's doing. If you're not going to store anything in IndexedDB, obviously you wouldn't pull in that package. So each of these sources have a common attribute, which is that they provide access to data in some fashion. And they also implement one or more of a set of interfaces that sources can conform to. And so here I've listed which of the interfaces, which of these standard interfaces the first-party sources implement. So you can see there's a different set for each of these, except for IndexedDB and local storage share the same ones. As you might imagine, right, these bottom two you would imagine being used for offline storage, and so it makes sense that they would kind of play a similar role. So we're going to talk a little bit about what each of these interfaces do, because having a basic understanding of them is important to understanding how sources interact with each other, which is sort of the whole, in my opinion, kind of like it's the real magic of Orbit. So updatable means that a source has an update method that takes a transform. Transform is a description of a change to the data, and returns the updated records that result. Queryable allows sources to be queried via a query method. The query method receives a query expression and returns a record set as a result. So this is important, that the fact that this returns a record set as a result means that this is almost always going to be application code facing, right? So it's when you're asking a source, and it's usually the memory source or the store, you're saying, hey, give me some data back. According to this criteria. So something worth noting there. Pushable allows you to call a push method on a source to put data into it. Pullable is sort of like queryable. It receives a query expression, but instead of returning a record set, it's returning an array of transforms. What that means is that pullable will typically be used between sources when they're looking to share data. And I'll describe to you, when I describe how a memory source and our JSON API source kind of interact, it's going to use pullable, and I'll describe how. And then finally, syncable, which is, again, one of the other really awesome parts of Orbit, applies a transform or a set of transforms to a source by calling sync. And again, this is rarely something that you will call directly in your application code, but that will be called between sources, as I'll describe in a second. So armed with this information, let's think about what kind of sources do we need in our app to fulfill the feature set that I described. Whoop, that was not the build order that I was hoping for those animations. Let's just get it all on screen. One more. Yes, all right. So the memory source at the bottom, this is going to be our application code's interface to our data. When we want the profiles to display on a page, we're going to query that memory source. That memory source is going to query, in turn, send its query up to the JSON API source. And that JSON API source is going to talk to our API in the cloud. Once that data comes back, we will then sync that data from the JSON API source back down to the memory source. And when it comes into the memory source, we want to sync it to our local cache. And I put a question mark there because at this point, especially as I was first kind of conceptualizing this, that was not one of the 4 options that was a first-party source. So I was hoping I would be able to make my own to do this, since IndexedDB was an option. In my case, our app uses Cordova, so we wanted to be able to dump it onto our native SQLite database. So I figured I could probably do that. So let's assume for the sake of the diagram that I could. And this is probably the part where I got the most hung up in trying to make this idea into reality. The lines around sync, I probably didn't quite have drawn correctly. And so the concept that I was missing is that in Orbit, there's an idea of a request flow, which are what happens when you make a request to query or with a query or update, and how that it flows between sources. And then a sync flow, which is the result of that query or update. How do those mutations flow back down through the rest of our through our sources and eventually give us a result? Sam.
I'm just being a little confused.
Yeah.
So stepping back, maybe like an analogy to Ember.js would help. So the application code that points to memory with query update, that's like the equivalent of calling store.find record.
Yep.
Or like user.save or whatever.
Mm-hmm.
And then the idea being that is the idea with the sources. So we're looking at 3 sources right here.
Mm-hmm.
Is one of them the source of truth? Is the idea that after an operation, one becomes the latest source of truth and needs to sync that source of truth across all sources?
Great question. So the question was, I think to summarize, at least the last part of the question was, which of these 3 sources is the source of truth? Is the idea that kind of after the operation, they all have the same data, or one of them is the source of truth? And the design analogy that's used to create these is Git. So you can think of each of these sources as a Git repository, sorry, as a not as its own Git repository, but as a fork, say, of a Git repository. And so commits in Git, right, may not exist in all of the instances of the same Git repo at any given point in time. But if you pull, and those things now become in sync, now they do have those same commits. In Orbit, these are called, instead of them being called commits, they're called transforms. And so each of these sources has a log of transforms. And when sync happens, sync is basically an operation that says, hey, I got a bunch of transforms. What's your latest? What do you have? Which ones do you need? OK, here you go. And then it says, hey, great, thank you very much. Now, memory source, I now have the latest information that JSON API got from the cloud. Now I've got it here, and I can fulfill my query, or I can update my live query with the latest record information. Does that answer your question?
I think so. So if memory had like 1, 2, 4, JSON API had 1, 2, 3, when you sync them, they're both going to have 1, 2, 3, 4.
Yeah, a sync is a directional operation. So it's going, in this case, we're syncing from JSON API to memory. So if there is stuff that got into the memory store from another way, say from our offline cache, then JSON API may not necessarily know about everything in memory. But if we sync from JSON API to memory, then memory is guaranteed to know about everything that JSON API knows about.
But not the converse.
Exactly. It's not a bidirectional sync. You could call potentially sync in the other direction if JSON API supported sync, but it doesn't. Because why would you need that? Why would you want that?
Because the purpose of the JSON API source is to have data from the JSON API.
Exactly.
To the network.
Exactly.
You're never going to query the JSON API source.
Exactly. Yeah. And there's a mistake on this slide, which is that on the right-hand side, the line between memory and JSON API, the upward-facing arrow, I think it says query update. This actually should be pull update, because we changed that query operation into a pull. And by the way, these lines I'm about to describe in the next section, these are not like, they don't magically get there. These sources don't know how to wire themselves up somehow. We're going to, in the next section, I'm going to describe how we tell Orbit to have these relationships between sources. Anyway, but that gets transformed, turned into a pull, which results in transforms being synced back down to the memory source. And so each of these sources, like you were saying, they have different purposes and they have different logic. So when we sync from JSON API to the memory source, what it's going to be doing is it's going to take those transforms, it's going to apply it to its own identity map. It's going to say, do I have any live queries that I need to update? Do I have any queries that are pending that I need to fulfill now that I've got my results back? Meanwhile, when we sync from the memory source to the local cache, that's kind of a whole other deal. What it's going to do is it's going to say, hey, Cordova, I've got some new information. Make sure that this is persisted, and it's going to write it to a database. So sources are they conform to the same set or a similar set of APIs, but they often serve very different purposes.
So just like in Git, there's actually not one source of truth. It's just by convention that we treat master as a source of truth, but it's not actually the source of truth. It's just one of many components.
Exactly.
So the same way to think about this.
Yeah, absolutely. Yep. Matthew.
Sorry, some of this is a little bit familiar to me, but the request flow was a little bit of a new thing. When you talk about request flow, do you mean the asynchronous process of like, I request something and then the server does work and sends answers back, like that whole thing, or do you mean the synchronous step of like the API has returned with data and now synchronously I can flow through the system and everything syncs up?
So the request flow, you can think the way that the Orbit docs and considers it is it includes any of the update, query, pull, or push operations, anything that's kind of starting a change or a request for data. That flow, what you want to make sure is that that's flowing in one direction through your sources. And then the sync flow is bringing the results of those changes back down through your sources. So it's very similar to data down actions up in Ember UI design. Where we get into trouble, the reason data down actions up became a saying is because when you don't do that, if you start to kind of like, if those arrows are pointing in all directions, it becomes really hard to debug stuff and understand how data is flowing through your application. And so Orbit adopts a similar concept, which is request up, sync down. In fact, I think that is the next slide. Yeah, request up, sync down. Again, this was one of the real, like, to grok this was one of the breakthrough moments for me in kind of understanding this. So let's next talk about these arrows and how do these arrows come to exist, right? The relationships between the sources, these data flows, if you will. And this is where we get into the concept that Orbit calls strategies. It lets you, in a very declarative way, describe what data flows you want to happen between sources. I don't have slides on this on purpose, but strategies are built on top of the fact that sources are evented. So sources are triggering events as you interact with them. Before query, query, after query, for example, if you were to call a query on a source. Same thing with sync, before sync, sync, after sync. And what strategies are doing when you give it this declarative thing is they're hooking into those events. They're subscribing to those events in order to build that strategy. And then if you deactivate a strategy, which I'll talk about, they then unsubscribe from those events. And in fact, logging in Orbit, which is essential to being able to debug these data flows, uses a strategy called event logging strategy, which basically subscribes to every single one of the events that sources emit and logs that to your console for you. So what we're looking at right now is the arrow between the store, the memory source, and the JSON API source, which is called YAP API in my app. And what we're saying here is that when we call before query on the store, we want to trigger a pull action on the YAP API source. And then we want this to be blocking. What does it mean for it to be blocking? It means that the query should wait until it gets results back, synced back down, in order to respond to the query. So the fact that you can have strategies be blocking or non-blocking means that you can start to see how you have a lot of flexibility in terms of what kind of interactions you want to be providing to users and between different types of sources. So maybe I care about queries being blocking or some subset of queries being blocking to the server, but when I'm pushing stuff back to my offline cache, heck, I don't want to wait for that, right? So I want that to be non-blocking, say. Ryan, did you have a question?
Yeah, is that kind of like Ember data now? Is that like background reloading?
So you can implement background reloading as part of this, or as a similar as part of this strategy. It would be a blocking false operation because you want to instruct your store source, your memory source, to return immediately. These strategies, also not shown here, can have a filter function where they receive the operation that's running, so in this case the query, and they can decide whether or not this strategy should apply to this particular operation or not. So you can start to get fancy and describe different situations. So in our app, for example, one of the things that we've done is we've said, hey, when you're making a request for a collection, you're running a query for a collection of records, an operation that Orbit calls find records. We want to wait. We don't want to wait for that. We want to return immediately. Anything you got in the store, I want right now, and then I want it to be a live query, so it'll just update when I get results back. Similarly, if I'm doing a find record singular, I'm requesting a particular resource. If I've got it locally, then I don't want to block. I want to give it back immediately, but I want to do a background reload like Ryan just asked about. And I want that request to go up to the server and potentially update it later. Everything would be data bound in my app. And so you can use filters to do that by, say, like checking, hey, does this thing exist in my cache yet? If it does, make it blocking. If not, it's non-blocking. So another example of a strategy, this is a sync strategy. And we're saying that from the app API down to the store, so this is the arrow that was pointing down with sync from the, from the JSON API to the memory source in the diagram. I want, anytime I've got data, I want to sync and I want it to be blocking. When you think about blocking, you have to kind of think about the overall flow. So if I were to make my query, this last one blocking, but make my sync not blocking, it would not work. It would not be waiting for the sync. So something to think about. So you have each of these strategies. You have your strategies that you've defined. In order to wire them up, the most effective and conventional way in Orbit is to use a coordinator, where you give the coordinator your sources and your strategies, and you say, hey, coordinator, activate. Activation is an async operation, and you can also call coordinator.deactivate. Why does this exist? Matthew, you have an idea? Forking is a good reason for this to exist. Another reason is sometimes you want to do some setup in the beginning of your application. So for example, and we can look at this code in a little bit, I have an offline store. What I want to do is I want to pull all the relevant data from the offline store and populate the memory cache before I activate all these strategies. Because when I do that, I don't want it to immediately sync everything back down to the offline cache. That would be counterproductive. So that's the coordinator. So I think we've touched on most of the major concepts in Orbit, and have touched on a lot of what it would take to make that diagram. One thing we haven't looked at yet is how do you make your own offline source. We'll look at that. Yeah.
As far as preparing the sources,
yeah.
You're suggesting that you would use those slightly lower level APIs to push things into the store before you actually boot up the coordinator, because you want to prep the world.
Yes. If you remind me, we get to section 5, which will be pretty soon. I will show you that code, or an example of real world use of that code. All right, let's introduce you to Ember Orbit. So everything that we've seen, all the code we've seen so far is just pure Orbit. All the concepts I've described is pure Orbit. Ember Orbit is also pure Orbit, except for there's a layer on top of it that makes it more Ember-y. I'm just going to run through kind of what are the things that Ember Orbit provides. So one thing is a more Ember-y model definition. Why would you want that? Well, if you remember, model definitions were pretty much POJOs in in pure Orbit. And if you want to use things like computed properties or other kind of CP macros, then it's nice to have a Ember experience here. So you can kind of see an example of our profile, a simplified version of our profile model here with a full name computed property. Ember Orbit brings conventions to file system conventions. So you're expected to store your models in data models, your strategies in data strategies, your sources in data sources. Coordinator and the kind of store service are automatically wired up for you as Ember services. So they're easy to inject where you need to using stuff that you're familiar with. And there's a bunch of things that you don't see that are really useful and save a bunch of boilerplate. So the schema that I just we showed earlier, where you are laying out all the model definitions, kind of and passing it all at once to a schema. With Ember Orbit, you don't have to worry about that. It goes and discovers the models in your data models directory and creates the schema for you. Sources, similarly, are automatically instantiated from anything in the data sources directory, and they're given the schema that it's created for you as well, since every source, when you're constructed, needs a schema. I mentioned the memory source is instantiated as store and is available as a service. Similarly, the coordinator is instantiated. It discovers the data strategies automatically with the sources, puts them all into the coordinator, ready for you to activate. Finally, there is, along with the convention, some configuration opportunities. And in particular, the one that is nice for making Ember Orbit work side by side with Ember Data, which we needed to do, is we can't have it be injecting a service name store everywhere, because that's my Ember Data store, and that would cause lots of problems. So in config environment.js, you can say, hey, I want my store to be known as Orbit store, and then it will be injected accordingly. So for the final section, what I want to do is fire up, is just switch over to my editor and look through some of the real world code, warts and all, and talk through maybe some of the questions that folks had about that. So let's try doing that. Let me mirror. Am I near mirroring? Is that mirroring? No. Thank you. All right, cool. Okay, so let's start with the question that Matt asked, which is about doing stuff to the sources before you activate your coordinator. So this is kind of one of the primary routes in our app. It's the YAP route. Is this the right spot? No. Here, let me.
How long have you been using code?
Not very long. Not getting used to it still. Here we go. Cool. So here we have this before load concurrency task that. Oh right. Okay. So this was we recently refactored this. This is called from a route, but it's not in the route code itself. Can you guys? Is this too small? Should I make this a little larger? I do this and. Collapse that. Okay, so down here at the bottom is when we're actually activating our main coordinator. It's injected as data coordinator. And so we're doing a bunch of stuff before that. The first thing that I am doing, and this was a result of injuries in the trenches, if you will, is I actually decided I'm going to create a different coordinator and activate that, because doing these things to these sources without logging is not a very good idea if you want to be aware like what's going on. So I created a coordinator with the same sources as my main coordinator, but with just an event logging strategy, and activated that. And then I found my local cache source, which is the offline source that we wrote. And it has a concept of kind of having a YAP ID, and it's almost like a namespace. So we're in YAP, like you only have one YAP open at a time, And so when I'm putting data in or querying data out, I want to be able to just kind of have that assumption and not have to specify it all in my queries. So I can kind of just say, hey, this offline cache interface right now, anything that comes in and out has this YAP ID. Then this is the part where we're kind of doing the prep, and the main objective is get the data that's in the offline cache, scoped under this YAP ID, out and put it into the memory. And so here's how we do it. We do local cache source.pull. Find records with no arguments means literally everything, every type, every ID. Normally you can pass a query to find a query expression to find records, but when you leave it blank, you just get everything. This yields a transform, and a transform. Sam.
Does pull return a promise?
Does pull return a promise? Yes. It's a promise. Sam.
So pull and query, those are two different things.
Those are two of the APIs, right? Yep. And if you remember, query is what you use if you are kind of like non-Orbit code, application code that's looking to get a set of records back. Exactly. And pull is what you use if you are looking to orchestrate operations between sources. So in our case, what we're trying to do is we're trying to take a set of transforms and that are in our offline source and apply it to our memory source so that it's warm and ready to go.
So the only thing with pull is like a GET request / users, like just that actual concept that you would like apply to other things.
Yeah. I mean, it's sort of like I don't know, maybe the difference between it's like the difference between like git fetch or it's like getting a git operation in something that's like git readable versus getting it in something that's human readable.
What's the connection between data coordinator is a service instance or a coordinator instance?
Both, which is part of what Ember Orbit does for you.
Okay, and then what is in sources that you wouldn't just look at sources for the local cache?
We're talking about this.
It's blown my mind a little bit that you can call lookup on line 20, and I guess you're getting, data source is singleton, but then there must be another instance if the logging is working, there must be an instance in the data coordinator.
Yeah, they're the same instance, which is nice. I would say in hindsight, looking at this, it probably would be clearer if instead I did like this.datacoordinator.sources.find or filter or something and like looked it up by name. They're the same. I mean, either way you look at them, look for them, they're the same thing. So once we have this transform, we can then call our store, our memory source, we call sync on it, passing the transform. And this is efficient enough to say like if the memory source already had a bunch of these things, it would apply just the difference. But either way, it's going to end up with all the data that's part of that transform.
So it's syncing that transform across all of the sources that have been loaded up?
It's syncing it specifically between the Orbit store.
Oh, that's one of the sources?
Yes.
Okay, gotcha.
So it's from the local cache source to the Orbit store source. Once I've successfully done that, I want to clear both transform logs because when I activate my coordinator, I don't want it to think that it's going to be syncing the stuff that I just pushed into the memory source back to the offline source. That part's a little confusing. It was a little confusing for me. But the transform log is essentially like a commit log in Git.
So they don't keep, it's like a transient log.
It's in memory, yeah. And then set the log level, deactivate my logging only coordinator and activate my real coordinator. And so once I do this, all the strategies that I've written, the ones that we looked at, the ones that make all those lines happen, it's now those are active. It's like, boom, the system's alive. Cool. So let's just look at a couple of things kind of in place. So here is my data strategies folder. And here is the actual version of update for if I'm making an update on the store. So I call save on a model, say, and as you might imagine, the Pojo version doesn't have save, but the Ember Orbit version has save. So I call save on my nice Ember Orbit model. That results in an update operation being made in the store. On before update, the strategy is saying push that data up to the cloud by way of the Yap API source, and I want it to block. So save is not going to be considered successful until the Yap API push is successful, which is based on the XHR request.
So blocking doesn't actually block the UI thread. It's just telling you the strategy that the problem should be resolved.
Exactly. Yes, that's a good point. Just for the folks at home, Gaurav observed that like blocking in this case, it doesn't mean you're blocking the UI thread, right? Because for example, there's a way that you can do a synchronous XHR request, which everyone says like don't ever do that, right? Bad idea. That's not what this is. This is again just saying like when is my update to the store going to be considered successful? When is my save going to be considered successful? And we're saying it's considered successful once we know that we've made it to the server and back.
Is the request strategy considered complete only when after update has also been completed?
Yes.
Could you block an after update and that's still blocking?
Yep. You could have some other strategy that's doing after update that I don't know what it might be doing. Maybe it's like looking for bad words in the response or something. Like yes, you can hook on any of those things. So then here's the real world sync going from our memory store to our offline store. So here we say it's blocking is false. You'll notice that I'm inheriting from either a sync strategy or a request strategy, or I'm instantiating that, I should say, not inheriting. So I haven't looked at the code underneath that part, but again, that's lined up very nicely with the requests up, sync down concepts. Like they're two different types of strategies. The catch stuff, I haven't really got my head around too much so far. Basically, it's a way that gives you an opportunity to do really rich error handling. However, if you don't do anything, then the error just kind of stays there and affects the next operation on this store. So that's why I'm doing this skip thing. This is basically saying like if there's a problem, keep going. So see me in a few months if that's a good idea. Ask if that's a good idea. This is pretty interesting. This is describing a source that I made called an Ember Data Store source. And as you might imagine, when you have two sources of truth, you have Ember Data and Orbit operating together, there are decisions to be made about like what models are owned by what data layer. And mostly I kept those separate. But there's some code, particularly around profiles, that we have some old features that expect that to be there with Ember Data, and some new ones that expect it to be there with in Orbit. And so we've solved that problem by making sure they're in both places. And let's take a little look at how that works. Are people curious about that? Or yeah? Okay, cool. Okay, so we'll start here. So this is our data sources, Ember Data. It's very small. It's just basically saying I'm a creatable thing. This is basically to make it friendly to Ember Orbit, right? So Ember's container expects a create method to be present on an object that you're giving it. So that's what's happening here. So let's look at the actual implementation here. Oops, that didn't work. I understanding code, I'm supposed to be able to command click around, but hasn't really worked for me quite yet. Okay, so here we are. We're an Ember data source. We're extending base source from Orbit data. And there's a interesting thing to figure out for me. I'm not super experienced with TypeScript. Orbit is written in TypeScript, as I mentioned before, and it uses interfaces. And in TypeScript, interfaces can bring implementations with them. So they function as much like mix-ins as they do like what I think of as a Java interface or something that has no implementation. And so I wanted this source to implement pushable, one of the types, right? But I couldn't figure out, I didn't know exactly how to do it. So I eventually learned that you can import that same thing, which in TypeScript is like done with @pushable as a decorator, @pushable. And here you can just pass your class to the pushable method, and it works the same way. So I have pushable kind of functionality mixed in here, and then I'm able to implement some of the underlying stuff that it depends on. I believe that push records is what it calls. Sorry, no, underscore push is one thing, and then push records is maybe the other thing, or maybe it's push raw. I can't remember which pushable calls. I can probably tell.
It looks like push records gets Ember data like instances.
Yeah, so maybe this is the raw one. Yeah, I'm guessing that's the case. In any event, we're able to have an API that we can call from the outside to push Ember data stuff in that knows how to serialize the record, transform it into the JSON API format that Orbit expects, and then delegate to push raw, which calls push, that pushable provides. What's cool about this is that it's its own source. Its logic is kind of completely separate from all that other parts of the diagram. This is not on the diagram that I showed you, but we can just kind of create this thing, and then have a sync strategy, and then push some stuff into it, and then it all of a sudden is participating in all the rest of the system. That includes like flowing down to the offline source. So that's where like the architecture I think gets really powerful.
How does it automatically start flowing to the offline source if you don't?
It takes one strategy in my case, which is the one that we were looking at. Ember data store sync. So I'm saying anything anytime Ember data store is changed, so if I call it that push Ember data records, right, and push stuff into it, that's going to result in a transform happening, change, mutation. This sync strategy is going to say flow from there to the memory store.
I see.
And then we have another sync strategy.
That goes from memory off.
Yeah,
Oh, cool.
exactly. Now, I don't have it in here yet, but I expect we probably will eventually. Very similar thing for WebSockets-based data, right?
So that's you basically marking Ember Orbit store, the in-memory source, as kind of like the source of truth for the offline store.
Yes.
Because basically, if you were to add new sources like Ember data or WebSockets, you would just push them into the Orbit memory source.
Yes.
So that anything that goes into there will automatically. Cool.
Yeah. Now, not only that, but here's something that's really cool. I actually made a slide for this, but didn't, but hid it because I didn't really get to refer to it as I expected. Let me see if I can find it. I think this is it illustrates the elegance of this pretty nicely. So this is how our project is structured. We have Yap Core, which is an Ember add-on, and then we have two apps that consume it. Yap Preview, which is a read-only preview, which is a web-based stuff. It doesn't need an offline store. And Yap Mobile, which is hosted by Yap iOS and Yap Android, which are native projects. And that is where we want the offline source. So at first I was thought, okay, this is cool. I'm just going to be able to create like kind of a dummy offline source for Yap preview that doesn't do anything, or maybe it just like stores it in memory or something. But I realized because these things are so nicely decoupled, all I have to do is not have an offline source at all in Yap preview, and just make, instead of having the offline source be here in Yap core, have it be in Yap mobile, add it to the strategy, to set it to the strategy, or to the coordinator with its own strategy, and boom, everything flows perfectly. So that was like, felt was a moment of win, let's say, as we were working on this. Let me show you I'm not going to go into detail, but just to have a sense, the implementation of the offline source, because this is probably one of the more challenging parts of it. Although I did basically, like I looked at the IndexedDB source code, and I was like, all right, I probably need to do all the same things except for delegate to Cordova. So that's what I did. So local cache source here implements pullable, pushable, and syncable. And we extend from Orbit source. We define ourselves with a cache. Not all sources, but a lot of sources have the idea of a cache implementation. And cache, I think it's not a great word to be used in some of these implementations, because sometimes they're storing data themselves, like in the case of the memory source. Sometimes they're just the logic of how to delegate to stuff, which is true in the IndexedDB source as well as in this one. So what you'll see is that as I scroll through here, there's actually no Cordova references in here. This is about 100 lines of basically just like saying, hey, I can sync, push, and pull by delegating to my cache. So we should look at the cache implementation. Oh, it's Cordova async record cache. So one thing that's cool is that Orbit provides a async record cache base class and a sync record cache base class that gives you a big leg up in implementing this stuff. This is my Ember service definition. So I wanted to make this available from Ember as well, so that I could, I'm not actually remember why I did that. In the beginning, it was for debugging purposes. I could have a handle on it. For testing also. So I wanted to be able to peek in here for test purposes and see what was up. But here you can see now we're implementing the requirements of the async record cache. You'll notice in these comments, what I've done here is I've reproduced the TypeScript signature of the method that I'm implementing, because it's a little confusing. It was a little mind-bendy to like remember what I'm doing when everything's in TypeScript in the base class, but it's JavaScript in the subclass. And probably it would be, I would say it's probably good to use TypeScript if you're using Orbit, if that's a thing for you, but we're not there yet. So here you can see that in order to get a record, when I'm passing an identity, I'm going to delegate to Cordova. This is the name of my plugin. This is the operation, the method or action on the plugin. These are the arguments that are sent to Cordova. So this means that my Cordova plugin's got to have a get record, get all records of type, remove record, get inverse relationships, blah, 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 get all records. And then we wrote a Cordova plugin for iOS and Android that implements those things by talking to SQLite. And then it worked. So that's kind of roughly what this looks like. Some of the tricky things to kind of figure out were like, do we want to be sending this data? Like, how much, in SQLite, this stuff is a string. Our JSON is a string. Where along the chain do we want to change it back to a dictionary in iOS or a hash in Android or a Pojo? Like, where is the right time? We decided to keep it as a string kind of for as long as possible before we parse it back to JSON and for Orbit. But like inconsistency there was one thing that bit us, and we had to figure out, get more disciplined about that strategy. What else are questions or other things people are curious about?
So earlier you had a slide where you showed like 3 different types of content, like the static, dynamic, and
Yeah.
the persistence. So how do you implement that persistence? I don't know if I'm not sure if you've already talked about it, but I imagine like if in your app you wanted to, in your application, to access the local storage, if it's offline,
Yeah.
would you create like a sync relationship from your JSON API source to your local storage, and then a sync relationship from your local storage to your app, and then just say not blocking?
You could try to come up with a strategy for offline where when you're handling a query, say in your memory source, you detect if you're online or offline, and you route it to one of 2 different sources. I decided not to do it that way. Instead, what I decided to do is to basically, when I boot, to take everything from the offline source that's relevant and pull it into my memory source. So I never interact directly. I'm never pulling data during normal runtime. I'm never pulling data out of the offline source. It seemed a lot simpler.
You could also tear down and recreate a new coordinator when you decide that the user's offline, right? And then
Yes.
Say I want my request to go to the
Totally.
user.
Yeah, that's an interesting strategy. Yeah, that could work.
Yeah, I was just curious about some of the other features in Ember data that people often reach for that are pretty high level, like polymorphism or record fragments.
Yeah.
What is this support for those 2 things? Have you run into it? Or?
Good question. I've not had a need for either of those yet, but I know just from observing in the community that there is either a bunch of work already merged or in progress on polymorphism stuff. I've not seen anything about fragments. And when you mention M3, that's an interesting question as it relates to Orbit. Like, does Orbit have a kind of answer for a similar thing, which is if I have a huge set of huge schema. The other thing that I'm reminded of is that I didn't mention is that Orbit is designed to be isomorphic, i.e. run in Node fine as well. And Paul Chavard, who Chichak on Twitter, etc., recently became a member of the Orbit team. He's been doing a lot of great work. He, I know, is running Orbit in Node as well. And what he wanted to, he did a setup recently and needed some changes to support it, where he wants to take the schema that he has on the server and expose it down dynamically to the client instead of having to ship the schema with the client. So that's, I thought that was pretty interesting as well. Ryan?
Do you have a example of stored forking, editing?
I don't yet. Yeah, we haven't done it yet. So most of our editing stuff where I would want to use that is in our editor project where we haven't introduced Orbit, but it would probably be way better than what we're doing now. Let me see real quick.
Looks like for that, would you create a new source?
You do not need to create a new source. I think you would fork the memory source. I think would be the most obvious.
Have a notion of forking built into that.
Yes.
I think they used to be able to instruct it. Just say you can cheaply say copy this.
Fork is not fork, or numbers for forward store.
All right, here's the test for fork against the memory source. Let's see what they do.
Source.fork.
So we start off by updating the source. It's actually kind of fun because you can see some of the lower level usage here, like calling update directly on a source with an add record operation.
What does T stand for?
Yes.
Did it just show you when you hovered it?
No, it showed me something useless, thanks to OSN. So here you go, source fork. That's the API.
Pretty good.
And then what happens after? Let's see.
So fork, cache, get record.
You have fork point. Ooh, so this is like very giddy. Transform log.head. You're asserting that the fork point is pointing to a particular point of the transform log, and that the base, fork.base is the same as the source. Oh yeah, okay. Merges transforms from a forked source back into a base source. So we fork, we make a change, source.merge fork. So it's very Git-like. Yeah.
Does he have a test that resolves like conflicts or something?
That's actually a good question. If you have conflict,
Let's
Is there like
see.
a function that can say which one wins or?
Rebase.
Rebase.
child.rebase. So that would like bring in all the log entries from the original source where the fork came from.
Yep. Maintaining only the unique transforms.
Wow. Pretty cool.
Here we go. Rebase orders conflicting transforms in an expected way. It doesn't quite deal with conflict resolution. Search for.
Well, it does in a certain way.
That's the only time conflict appears in this
Read
file.
the comments 1 through 5 there.
Sorry.
Read the comments in this test. Step 1.
Oh, step 1, fill the source with some data. Step 2, create a child source. Step 3, update the child and the parent source in any order. Step 4, make sure the updates were successful. Step 5, do the rebase, and then assert.
So gassy giant wins because the gas giant was
Oh, because it was your child. So you're doing a child rebase?
this child.
Well, that's the child cache, the source cache.
Child.
So that's gassy join.
It's,
The last assertion.
you're rebasing, which means you're playing the fork on top of the.
Yeah, so it's not merging at this point. You're just rebasing.
Yeah.
But maybe that's how you solve your conflict.
Yes, that's
You
actually correct.
rebase, so that's how you decide you win. You
Yes.
say I win because I replay the transforms that I have on top of whatever is
Mhm.
Interesting.
and then you merge yourself back in.
Right.
So if you were to go to Google, Docs, Word, or whatever, and like you're offline and you come back online, you could rebase and then see if you could apply the things you did in the subway or whatever
Mm-hmm.
to the document.
And so the question is, does rebase possibly fail sometimes?
Yeah, exactly.
Well, you could implement, this is a source. So if you implement rebase yourself, now you have the keys to the kingdom.
Or something.
Yeah. Cool. I think that's. Oh, so I did have a list of a few things that I didn't mention. Oh, a couple things. So I've been contributing some to Orbit, specifically around some of the Ember Orbit work to be able to work side by side with Ember data rather. And then the other thing is building out some of the extensibility APIs for the JSON API source. So it's a pretty ambitious project, Orbit. Like the JSON API source, like little sub package by itself, like that's a big project, But anyway, it's getting better. So we have this new idea of a request processor that I was able to subclass and do some like interesting. One of the problems that you run into with storing stuff offline is what happens when you have deletions on the server. How do you clear that stuff out of your local cache? There's some different models, approaches. We are using one called the tombstone approach, where basically when we're querying the API, we're passing along a timestamp and telling it, hey, this is kind of when my last query was, and the server will send down any deletions since that timestamp with the results as tombstone records. So that's not something that Orbit has any kind of concept of, but by creating this request processor concept, we were then able to have the right kind of hooks to deal with that ourselves. So then, let's see, there were a few other notes. So I mentioned, we talked about store forking. WebSocket source I touched on.
So you've done WebSocket source, or you're building that right now?
I have not done it yet. I think that T-Chalk's working on one. And I think something like that will probably become a first-party package, I would expect. We didn't talk about client-side IDs versus server-side IDs, client-side assigned IDs versus server-assigned IDs. But that's something that Orbit has some richness around. Bulk operations will come with the JSON API operations.
Yes, I think part of the odd thing is like any of the stuff of how do I deal with my API is effectively up to you, but it also means that it's like balloons and possibility, right? So like you can decide like if I have like 5 transforms that each make a single change to an attribute, you could save 5 times, or you could try and roll them up and save once. Or you could try and put them into an operations list with other stuff and make one request.
Yep.
There's like a myriad of like possibilities.
But realistically, you're not going to be writing that code. Like if you were to use Ember today, you would just use a JSON API source. Like you wouldn't write all that. You wouldn't write a source yourself just to save your API.
If you have an existing API.
I would say the JSON API source is flexible enough that you can probably, for most RESTful APIs, you could probably override it. And, yeah, there's a serializer thing that you can pass in your own serializer class, that kind of stuff.
At this point, DGET has written like 9 different serializer libraries between this and JSON API resources.
Does YAP have any like, non-JSON API, non-REST endpoints that you just?
We do, but not in our mobile app.
Would you, if you were going to talk to those, would you implement another
source?
Yeah.
Probably.
Okay.
I mean, if I was going to use Orbit to do it, it depends on. Yeah, it depends on what needs to happen with it. If it needs to does it need to come back into the system, right? Back into my sources flows. There's some mutation that's going to result from it, that kind of stuff. I did have a slide on resources. So the Orbit.js.com site has the guides are there. They're really well written, but they're not comprehensive. The Gitter channel is relatively active. DGEB, T-Chalk, I hang out there. And then the source code I mentioned is in TypeScript, well tested, clean, worth reading. Cool. That's it. Thanks for sticking around.
Cool. That was awesome.
Yeah, thank you.
Sure.